To start our training with FastBeam, we'll come over here to the Applications and Components panel and we'll double click on the icon to launch the tool. From there, we can go ahead and minimize the Properties and Applications and Components pane. Now, when you look at the interface here, the very first thing that we need to do is set some of the base defaults. Let's say we're going to start by setting up our columns on the project. Here I'm going to set the bottom of base plate elevation or top of footing elevation as -2 foot as an example, and let's say the top of our roof steel or the top of our columns are going to be 20 feet. We'll enter in these two values here so that way they can be saved away as a default. Now what I can also do is I can go ahead and create a brand new group which will allow us to basically come in here and reset these profiles as needed. So now I can type in the profiles of my columns. So let's say a W8 by 40, we'll then just add that. Then we could say W12 by 53 as an example, add that. And then we'll do even a HSS 6 by 6 by 3/8 as an example. And let's even add one more, W14 by 74 for say some bracing columns. Once we have all of our profiles in here that are going to be specifically used in this group, or in this case it's going to be columns, we'll just go ahead and type in the word columns up here at the top, and then we'll just press the save button. As you hover over each of the buttons, it'll actually give you a tooltip explaining what that button does. Now we have these profiles saved away. We have the correct elevations properly set, and now we're able to actually start going ahead and putting in steel. Now before we do that, we might also come in here and say show labels. You can press the button to toggle this on or off, or just press in the checkbox. And the labels are basically going to be really helpful as we're putting in or modifying steel, so that way we can see the end elevations as well as the profile directly in the model. This helps make sure that everything is accurate and we can check as we go. To start placing steel, all we need to do is press the button of the profile that we want to place, and as long as nothing is selected, it's going to think that it's a creation event versus a modification event. So let's go ahead and put in some W14 by 74s. It says pick the start and the end point to place the beam. Now to tell the tool that we're actually working with a column, all we do is we simply double click in the same location, so that way it knows that you're putting in a column, and it reads the start and the end point elevations here to place the top and the bottom of the column. Once you're done, just right click and interrupt. Now when we've placed these members, how can we be sure that the correct properties have been applied? For instance here, we want this W flange column to be called column in the name, the correct material property, the correct class, as well as the prefix for part and assembly numbering. Now in order to control this and set this up, what we can simply do is come in here to settings, and here you'll see that upon first launch of the tool, a profile definitions XML file is created inside of the model folder, and then these different definition rules are then loaded and created. Now the way that this works is that you can actually come in here and first define the member type. So at the very top you'll see that any profile that begins with, so we have either begins with or contains, if any profile that we're creating begins with W and it's a beam, then it's going to get these specific part properties. Then if it's a column, we want it to get slightly different part properties, including the name, as well as some of the number prefixing, as well as the class number. Now these are by default set up for the US IMP and the US metric environment, but they can easily be modified and set up and saved away to work with any global environment profiles. At the very bottom you'll see that there's channels and angles as an option here, and you'll notice that there's a plane position property, and these are default to right because angles and channels, oftentimes we want the picking points to be lined up with the back face of the channel and the angle, and so that's what this allows you to control. Then lastly here we have a contains rule. And so for instance with joist girders or joist, you have for instance 36G as a girder designation. It doesn't necessarily have the profile starting with G, but G is inside of that profile and is the way that we want to filter by that. In the case of joist, we oftentimes will use K-series joist as an example. So maybe we'll change this to K, and then anything that has a K inside of the profile or contains K will then be using these specific properties. So let's go ahead and save these settings. Now one other thing here is that oftentimes on larger projects, you want to set up phase numbering. And what many detailers do is they set either the prefix, including the phase number, or they set the start number to be a multiplier by the phase number. So for instance, phase number would be start number series 1000 for phase number 1, phase number 2 would be 2000, phase number 3 would be 3000, etc. So you can use either one of those options here when you're creating or modifying any of the parts. So let's go, for example, and do prefix. We'll then say whether or not we want this on both the part prefix as well as the assembly prefixes here. We'll press save. And now we can go ahead and go back to the model and start modifying these columns to make sure that they are appropriate to the correct phase number. Let's go ahead and go to the Manage tab here. We'll go to our Phase Manager. And then what we can do is underneath the Phase Manager, let's just go ahead and add another phase. We'll select these 4 columns here and we'll make sure that they're phase 2 and press Modify Phase. Let's close down the Phase Manager. And then what we'll do is we'll select all of these columns. And since we know that they're all 14 by 74, we're just going to go ahead and do a 14 by 74 pressing the button, which then just goes back and it actually just modifies those existing columns. Now, when I do this, and then I just go to the properties, you'll see here that the part prefix as well as the assembly numbering prefix for these columns in phase 2 have a 2 in front of them. If I go over to the ones in phase 1, these are now 1W and 1C and have that phase number in the prefix. Now at any time, if we want to go ahead and get rid of these elevation and profile references, we can just redraw the view here. And let's say that we want these last 2 columns to be HSS 6 by 6 by 3/8, and these are going to only be 10 foot tall going to the 2nd floor. Now the way that I modify this is first I'll go ahead and modify the ends. So you'll see that the profile is still the same, but the elevation is now different. And then we'll just modify the profile shape. If you need to modify the rotation property, you can again do that here within the Part Properties dialog box. Now we'll just go ahead and redraw the window to remove those graphics. And now we have those columns modified. Let's go ahead and just practice this again by selecting on some other columns. I'll go ahead and select these pieces here. And then I'll just go ahead and change these to a W12 by 53. Then again, if needed, I can change the rotation here to front and just press modify for those specific columns. And now we have this updated. Now, if you've manually modeled in any steel and you want to quickly get the existing properties that are there, you can select on that particular column or beam, and you can just go ahead and press the Get button here. This will then pull in the profile of that specific member, as well as the start and the end points here in the elevations. Now let's say, for instance, that you make a mistake in one of your profile creations here. So we'll just go ahead and put 7 and add that in here. And then we see that this isn't what we actually want. And so what we can do is we can just press remove. And what remove will do is it's going to remove the last profile slot that's been added here. If you continue to add profiles in, then basically what it'll do is it'll just take the next slot. And then once you get to the last slot, it's just going to continue to replace this last slot with whatever the latest profile is. Again, we can just remove these if needed. Once you've made those changes, then you just press the Save button here, so that way that existing group has these profiles now updated and saved into it. Now that we've got the columns in, let's go ahead and start creating our profiles for beams. I'm going to go ahead and define a new group here, and I'm going to call this Beams once we save the profiles. And what I'll do is I'll just start typing in some common profiles. So let's say W12 by 14. We'll just add that. W14 by 22. And I'll just add a few more profiles here as an example. And there we go. We've got some pretty common profiles that we might use here on our structure. Now, you might have different beam sizes on your floor levels versus, say, your roof level. Sometimes the beam sizes will get smaller because the slab isn't necessarily as thick or it isn't full slab concrete. And so you may create groups here for floor beams or second floor as well as roof, etc. And you can create as many groups that you'd like. Now once you again change any of these profiles, just press the Save button so that way those profiles are saved with that particular group. Now, in this particular case, I may actually want to set a default top of steel elevation for this group of beams. This is also why you might have a second floor, third floor, roof, etc. So let's go ahead and just type in 10 foot on both the start and the end point, and then I'll just press save again. Now the reason why this is handy is that when you actually create beams using the profile buttons here and you have the locked feature set, what's going to happen is it's going to use the elevations here when placing the beam. So let me show you this. If I press W16 by 26, notice that I'm picking at the top of the column, but it's actually putting the beam here at that 10-foot elevation. So this is a great way to work in 3D and not have to actually translate yourself up along that column to get it to the correct elevation, or having to change your view plane in a 2D view in order to do a mezzanine or something like that. So let's say, for instance, we had a couple of beams that were actually at 12 foot. So we'll just stop this beam command, come back in here, type in 12 foot, 12 foot, and then we can just come in here and say W21 by 44, and again, we'll just pick, and you'll see that now those newly added beams are at the 12-foot elevation. Now at any time, if you want to come back and modify those, let's go ahead and just say get here on these 10-foot elevation beams, and then we can select on these beams here, and then we can just go ahead and say modify the endpoints, and you'll notice that they then stretch down to the 10-foot elevation. Now there's going to sometimes be cases where you actually want to pick the specific points to place your beam, and you don't want it to hold to these elevations. In order to do that, you simply press the unlock feature here, and now when I activate the beam command and I press the first and the second point, the beam will actually be inserted at the picked points. Let's go ahead and undo that beam, and then we'll also set the lock back. Now let's go ahead and model in some intermediate floor framing here. So we'll go ahead and specify that the number of beams that are going to go in between this bay is going to be 2. And then we can simply come in here and say W12 by 14. We're then prompted to pick beams rather than picking points. So we'll pick this beam, then this beam, and here you'll see that 2 beams equally spaced are then placed inside of those bays. Now we can also go ahead and select on parts and still continue to use things like the copy command. So let's go ahead and copy this over here. And then what we can simply do is if these beam sizes are slightly different, we can then just come back, select those pieces and modify them. So that way those particular profiles are then updated and changed. Now let's go ahead and say we repeat this process for the second floor to roof. So we'll simply copy from this level to the roof level. Now from here, we're going to be working at the 20-foot elevation. So we'll go ahead and change our start and end point defaults here. And I might even come in here and say roof as this group as an example, and we'll press save. And it will remember both the profiles as well as these end elevations. Now I'm going to potentially have a sloped roof here. So what I can do is I can actually select on these 2 columns, and then I can go ahead and type in that these are going to be 20 foot 7 inches and a half as an example on this top of column, which the endpoints of columns are always the magenta end here at the top. Now what I can do is I can say let's tell it to adjust the secondary framings. So it's going to do a search around the top end of the column, or if you're modifying the elevation of beams, it looks along the length of the beam and it looks a certain distance vertically here to see if it actually can modify the secondaries that are framing into it. So let's take a look at how this works. If we say modify, you'll notice here that the beams framing into this column, both this one as well as these 4 here, have all sloped and modified. But then what about these secondaries here? Well, what we can do is we can simply say get, so that way we've got that elevation, and then we can just go ahead and say modify here, and you'll see that the secondaries update. This is the same elevation, and we simply select that and modify that, and you'll see that that updates. So as long as you have the adjust secondaries checkbox option selected here, then this will work. Now over here, we need to go ahead and actually say get because the elevation is different on the start point end. So we'll then just get that, we'll select these individual members, or we could select both of them, press modify, and now we have the geometry all sloping. Now again, we can also repeat this process over here for these columns. Let's go ahead and select on these, and then here we're going to make this 21 foot 6 as an example. We'll then just go ahead and modify these ends, and you'll see the geometry then changes. Now what we can also do again here is we just select on this piece. We can see that this is the endpoint, modify it, and you'll see here that it grabs those secondary beams and it slopes the roof framing to that. Now let's go ahead and add in an angle here. So we'll do angle 4 by 4 by quarter as an example, and we can add that profile. Now here I'm going to again go ahead and choose the unlock option because I'm going to be placing this beam along this sloped framing. So I'm going to simply have that profile, I'll activate it, and then I'll just go ahead and pick along here. And actually here's a good case of what I didn't expect is that I need to actually change this back. So I could put 2 angles in, or I need to change this back to 1 or 0, something less than the quantity of 2, and then that way it's prompting me to pick points. Before, when I had this at greater than 1, it's basically saying that, oh, you're trying to put more than 1 angle in, so you need to pick the parts to define that. So here we're just going to go ahead and say nearest, and we'll pick along there, and now we have an angle placed here in the model. Now let's go ahead and do the same thing. Place in another object, and then we can see here that maybe these rotations are not exactly the way that we want, so we can modify those if needed. So if we come in here, we can go ahead and say let's look at the below face and modify those, and now we're looking at the piece of that or the side of that angle that we want. And we can also come in here and then we can switch this potentially here to on plane left, modify those, and now we have the angles somewhat oriented and lined up the way we want. But we can see here that one angle needs to actually be towed the opposite direction. Maybe we're doing a roof opening and a roof frame here. And so if we select on this piece here, if we press on the swap ends, it's actually going to go through there and it'll just swap the start and the end point, so that way the angle is towed the opposite direction. This is also the same for channels. Let's go ahead and go in here and type in C8 by 11.5, and we'll just add that. And then now I'll select on both of these profiles here, and we'll just modify them, and you'll see that they are now placed in correctly. So again, the rotation is set, the profile is modified, and then also all the prefixing and the name and material grade are also adjusted as the profile changes. This is really great in the sense that you don't have to load up saved away settings or just make sure that everything is properly changed here. It's automatically doing that here from within the settings definition. Well, that covers the training of the main concepts behind FastBeam, and ultimately the biggest benefits that you're receiving are that there's a lot less typing. You have your common profiles and you have your saved away properties that are associated to those, and you're just simply selecting and clicking to either add or modify those beam properties in the model. Then basically here we have better self-checking. By seeing all the temporary end elevations and graphics for the profiles, we can easily self-check as we're inputting or modifying our framing. Then also we can do quick sloped framing geometry or complex roof geometry instead of having to move things manually or measure those values, especially on beams where there's no end elevations in the normal part properties. Here we can simply define those properties and we can modify the main supporting framing, and then all the secondary framing adjusts with it.